Multiplying with decimals. Multiplying numbers where at least one of the numbers is a decimal. Step 1. Align the numbers vertically and multiply as if the numbers are whole numbers. So we're not trying to line up the decimal points. In the last video, when we're adding and subtracting with decimals, we lined up the decimal. This time, you're going to multiply and basically ignore the decimal point for at least the first part of the problem. Just multiply just like we've done before. Here's the next part of it. Step 2. Find the sum of the decimal places by counting the digits to the right of the decimal point in each number. Then add each result. Okay, so that's kind of unclear what that means, but we'll go through it. Step 3. Starting to the right of the answer obtained from multiplying, in step 1, count from the right to the left the same number as the sum of the decimal places determined in step 2. Then insert the decimal point. I know, that seems kind of weird, huh? Okay, so maybe pause the video, write down those steps, and then we'll get to doing some examples here. Okay, so first thing is, here's our first example, 0.111 times 0.7. Just write it vertically. Make sure that the last number is lined up. The last number, so that 7 is below the last one. And now just multiply. So 1 times 7 is 7. So we're going to get 7, 7, 7. And that's it. Everything times, if you go to the next numbers, everything times 0 is just going to be 0. So there's no numbers there. Okay, now count the numbers to the right of the decimal in the top number. What do we get? 3. Right? There's 3 numbers to the right of the decimal in the top number. How many numbers are to the right of the decimal in the bottom number? 1. So there's 3 places to the right of the number, to the right of the decimal in the top number. 1 place to the right of the decimal in the bottom number. Add that up, and that gives you 4 places. So now we're going to move the decimal point 4 places to the left from the far right. So see, right now the decimal point's at the end of the 7. So if you move it over 4 places, you're going to have to add a 0 in front of the 7. So 0.0777 will be our answer. Because there has to be 4 numbers to the right of the decimal in our answer. Because the top number had 3 places, the bottom number had 1, so 3 plus 1 is 4. So there's your answer, 0.0777. Okay, let's do another one. Find the product. Product is another name for multiplication. 0.34 and 2.7. So let's write it vertically. Again, don't worry about lining up the decimal points. Just go ahead and multiply. See, 4 times 7, 28. 3 times 7 is 21 plus 2, 23. Now to go to the second row, we need to add a 0. 4 times, I like to cross out that top number so I don't get confused. 4 times 2 is 8. 3 times 2 is 6. That's it. Now if you add those numbers up, it gives us 918. 8 and 0 is 8. 3 and 8 is 11, but we've got to carry the 1. 8 plus 1, 9. Yep. Okay, now we're going to count the digits to the right of the decimal point in each number, and then add that together. So how many numbers are to the right of the decimal in the top number? 2. And how many numbers are to the right of the decimal point in the bottom number? 1. That gives us 3 altogether. 2 digits from the top row, 1 digit from the bottom row, which equals 3 digits. Okay, so here's our last step. Starting to the right of the answer, count from right to left the same number as the sum of the decimal places determined in step 2. Then insert the decimal point. So we have to just move it over 3 places. The answer will be 0.918. If it was 4 places, we have to add a 0, but we don't have to add a 0 this time. Now, if you don't have that 0 in the ones place, if you just have 0.918, it's not wrong, but proper math format is to have a 0 in the ones place if there is no ones place. So most likely your teacher wouldn't take off points, but double check with your teacher. A computer, if you had to put this in a computer program, they might mark it wrong if you don't have a 0 in the ones place. Okay, let's go to the next problem. Find the product of 3.14 and 14. Okay, so now we're going to, step 1, align the numbers and multiply as if whole numbers. So just multiply 3.14, forget about the decimal in front of the 1 after the 3. Just multiply as usual. 16. So you should get 4396. If you need to pause while you work that out, please do so. Okay, now count the digits to the right of the decimal point in each number. So on the top, how many digits are to the right of the decimal point? That's right, 2. And in the bottom number, how many digits are to the right of the decimal point in the bottom number? That's right, none. So 2 digits from the top row, 0 digits from the bottom row, which equals just 2 digits. So now step 3, in our answer, count from the right to the left the same number as the sum of the decimal places, determined in step 2, and then we could insert the decimal point. So move the decimal 2 places to the left, starting from the very end of the number. So move it over 2 places, so that would be in between the 3 and the 9. Boom. So 43.96 is our answer. And sorry about that. I don't know why it says feet. There's no feet here. Oh well, we'll just kind of scratch that guy out right there. Whoops. Pretend like you can't even see it. Okay, let's go to the next problem. Procedure for multiplying by powers of 10. Powers of 10 means numbers like 10 or 100 or 1,000, because a power is an exponent. So 10 to the first is 10. What's 10 to the second? 10 to the second is 100, because 10 to the second means 10 times 10, which is 100. And then 10 to the third is 1,000, which is 10 times 10 times 10. Okay, so here's the procedure. Now, it's really a shortcut. Aren't shortcuts great? I think so. The shortcut is to move the decimal point to the right the same number of places as there are zeros in the power of 10. So the number of zeros, for every zero, we move the decimal point to the right. Now, 10 squared, when we have exponents, 10 squared is 100. 100 has 2 zeros. 10 cubed is 1,000. 1,000 has 3 zeros. So if it has an exponent, the number of zeros is the same number as the exponent. Okay, so for each zero, all you have to do is move the decimal point to the right. Let's look at the first problem, 6.37. How many zeros, we're multiplying it by 1,000, how many places do we have to move the decimal point? There's 3 zeros, so we're going to move it 3 places. Since there's 3 zeros, move the decimal point to the right 3 places, so we're going to have to add a 0, so 6370. Okay, the next number, 7.295 times 10 squared. 10 squared has how many zeros? It has 2 zeros. It's going to be the same number of zeros as there are as it is the exponent. 10 squared is 10 times 10, which equals 100. So there are 2 zeros, same as exponent. Move the decimal point to the right 2 places. So we have to move the decimal point 2 places. So move to the right. Where's the decimal point going to be? Right, between the 9 and the 5. See, it's a lot easier than writing it all out, putting zeros everywhere. It's a lot of work. Shortcuts are always great, so try to make use of that shortcut. Okay, let's try another one. 0.8675309. Oh, that sounds like a number. Times 1,000. Okay. Well, there's 3 zeros, so we're going to move it over to the right 3 places. So if you move the decimal to the right 3 places, where will the decimal point end up at? Right, between the 7 and the 5. So 867.5309. Yeah, if you're from the 80s or you like 80s music, you might know that song. It was somebody's number. I think her name was Jenny. Okay, next problem. Ten squared is 10 times 10, which is 100. So there's 2 zeros. Move the decimal point to the right 2 places. So where's our decimal point going to be? Right, between the 3 and the 1, because we have to move it over 2 places to the right. So 3.14. You might know that number already. That's a decimal approximation for pi. Pi is a Greek letter, and its numerical representation is 3.14. We'll talk about this number further when we get to circles. Okay, that was the end of our video, so I'll see you here for the next one. Have a good day.